Hello, my name is Youngjin Jo from Ilsan University. I present the defect-mediated control of ferroelectric hysteresis in epitaxial BNKT thin films. I will introduce the effect of local disorder on the ferroelectric hysteresis loop. Let's assume that operation state ferroelectric thin film on the bottom electrode and connect the conductive tip on the film surface. When applying an electric field, down domain nucleation is induced by an electric field. The typical ferroelectric thin film exhibits the single hysteresis loop. On the other hand, in case of ferroelectric thin films with a local disorder like edge dislocation, the down domain is still nucleate, but when the domain will reach the local disorder, the domain where motion is delayed than the first case. In other words, domain where velocity is decreased. Domain where pinning occurred at a local disorder, and domain where pinning makes pinched hysteresis and double hysteresis according to the strength of pinning. But the study on the domain where pinning effect by screw dislocation has been rare so far. Study the domain where pinning effect by screw dislocation, we choose the BNKT. Why choose BNKT? It is an excellent platform for studying the dislocation effect on ferroelectric hysteresis, because the BNKT is susceptible to vacancies, doping, strains, and data compresses. To induce vacancies, we paid attention to the ASI components of the BNKT. The BNKT includes bismuth elements, and it can easily be volatile at high temperatures. Then, we can induce bismuth vacancy at high temperatures. Normally, the typical BNKT lattice volume does not change at low temperature, which induces compressive strain stress, resulting in single C domain. On the other side, bismuth ions in the BNKT are very sensitive to temperature and can be volatile to produce bismuth vacancy at high temperatures. The BNKT lattice with bismuth vacancies lead reduction in the lattice volume. It obtains tensile strain, resulting in forming the A domain locally. The mixed C and A domain configuration results in spiral growth, induced screw dislocation at the domain boundary. The screw dislocation causes domain warping, then BNKT thin film would show a double hysteresis loop. To control the formation of bismuth vacancy in BNKT, we found that the deposition temperature during the film deposition can be used as a controlling parameter. The bismuth vacancies are very sensitive to the deposition temperature as reported previously in bismuth ferrite thin film grown by first laser deposition. Similarly, the BNKT thin film was deposited by first laser deposition with controlling deposition temperatures. In this work, we noticed that the ferroelectric hysteresis loop is strongly dependent on the growth temperature during first laser deposition. For BNKT thin films grown at high temperatures, it was evident that screw dislocation were induced by spiral growth on the film surface. If you want to see a detail, please check my poster. Thank you for your attention.